Hi, everyone. Welcome to Organic Chemistry in 5 minutes or less. Today, we're going to be talking about radical chain reactions, specifically a bromination reaction. So when we talk about bromination, we're talking about replacing a hydrogen atom with a bromine in a given alkane. This reaction can also happen with different selectivities, which means you're preferring one. Here's an example of this reaction. If you react propane with bromine, light, and heat, these are the two symbols for light and heat, right? H nu for light and delta for heat. You can arrive at two different products: bromination at the 2 position or bromination at the 1 position. Bromination at the 2 position is 97% of the product mixture, and bromine at the 1 position is just 3% of this reaction product mixture. So how does this reaction happen? Well, first there's an initiation phase, where the bromine is homolytically cleaved. Notice the two fishhook arrows, meaning that one electron is moving in this molecule. This forms 2 bromine radicals, and you can draw the bromine radical like this, or you can represent it as 2 bromines with 7 valence electrons. This gives you a hint that this is a reactive intermediate because it does not have a satisfied octet. This bromine radical will then interact and react with the propane itself. This is called a propagation step. So here, the bromine radical, abstracting the hydrogen from the 2 position. Notice again, all fishhook arrows. This leaves a radical on the secondary position plus HBr. And then in the termination step, the secondary radical reacts with another bromine radical. Remember, 2 were formed. This 2-bromopropane. The formation of this 1-bromopropane is exactly the same mechanism, but instead of abstracting the hydrogen at the 2 position, you're abstracting the hydrogen at the 1 position. Okay, so typical questions you might ask in office hour. Okay, and 2 questions you might ask at office hour. 1, why is the 2-bromopropane so much more favored than the 1-bromopropane? And 2, does this reaction occur with other diatomic halides? In other words, could propane plus chlorine in the presence of light undergo reactions, and what are those selectivities? Okay, that's been Organic Chemistry in 5 minutes or less. Thanks for tuning in.